Hello everyone, my name is Rohit Singhal and we were talking about the redox reactions. In the previous classes, I have started with the certain rules where how we can calculate the oxidation number of any element in any compound. The first rule I have stated with is an element present in free or uncombined state, for example, H2, Cl2, Na, Mg, the oxidation number is 0. The second rule I have discussed is for the ions. For the ions, the oxidation number is same as the charge on that ion, for example, Na plus, Mg2 plus, Cl minus. So, the oxidation number of Na plus is plus 1, Mg2 plus plus 2, Cl minus minus 1, O2 minus 2 minus. The charge on the ion is same as the oxidation number of that ion. Okay. For the next thing, I have separately deal with the two things, oxygen and hydrogen. Oxygen, I have said that is mainly present in generally present in -2 oxidation state called oxide. It can also present in 2 oxidation state, that in one is -1, that is peroxide, or it can present in a -half oxidation state, that is superoxide. So, oxygen I have discussed this 0, you know, for example, O2. Okay. I have discussed -2, for example, this is O2 minus called oxide, -1, this is O2 2 minus called peroxide, and O2 minus, that means oxidation number of -half, this is superoxide. Okay. So, these are the oxidation number, negative oxidation number we have discussed about the oxygen. Then we have discussed, or we thought that is it possible for oxygen to have a positive oxidation number. Then we just get back to our definition of oxidation number, what it is. So, oxidation number we discussed that it is a transfer of electrons, or it assumes the complete transfer of electron from a less electronegative to a more electronegative element. So, if we need oxygen to have a positive oxidation number, what we need a more electronegative element than oxygen. Now, do we have any electronegative or a more electronegative element than oxygen? Yes, we have. Fluorine is the more electronegative element than oxygen. So, in that case, we have two of the complexes known for oxygen and fluorine, one is OF2 and another is O2F2. In this oxygen, the oxidation number of oxygen is +2, and here oxidation number of oxygen is +1. Okay. So, this I have discussed about the oxygen. Then I have discussed about the hydrogen, that there are only two possibilities, for three possibilities actually, 0 when it combined, when it is present in uncombined state, that is example H2, +1 or -1. +1 when present with a less electronegative element, or let us say metals, or -1 when present with non-metals. Okay. +1 I have given examples. Okay, I have written the opposite thing, -1 with metals and this one with non-metals. Example H2O, example NaH. Okay. So, these are the three oxidation numbers I have discussed about the hydrogen. Okay. Now, we have just left with one or two rules to end up the thing with. I think this is the rule number 5, I think. Okay. There are certain groups which have the same oxidation number, means the oxidation number for the group does not change. For example, alkali metals. For all alkali metals, always the oxidation number is, for all alkali metals always the oxidation number is +1. For alkaline earth metals, group 2, for all the alkaline earth metals, that is group 2, the oxidation number is +2. For halides, this is always. Okay. If in any case an alkali metal group 1 or group 2 metals came in any compound, without even thinking twice, you can assign alkali metals a +1 oxidation state or oxidation number, and alkaline earth metals to be the +2 oxidation number. Okay. Now, for halides, What happens generally halides have a -1 oxidation number generally. Generally the oxidation number is -1. For fluorine, it is always -1. Now, you must be wondering that why it is so that fluorine has always an oxidation number of -1. It is because because fluorine is the highest electronegative element, or is the most electronegative element, is the most electronegative element. Okay. Fluorine is the most electronegative element, whereas chlorine, bromine, iodine, okay, these can have a positive oxidation number also. Generally these exist in a minus oxidation state number. Chlorine, bromine, iodine can have a oxidation number of negative. If it is negative, it will always be -1. If negative, always -1. It can have a 0, for example, in F2 Cl2, oh sorry, Br2 Cl2 I2. Okay. It can have a positive oxidation number also. Now, when it can have a positive oxidation state? Because the Cl, Br and I, there exist an element that have a more electronegativity than chlorine, bromine and iodine. What it is? Oxygen has more electronegativity than chlorine, bromine and iodine. Okay. So, it can have an oxidation number of +1, +3, +5, +7, it can also go up to. Okay. That I will tell you how to calculate the oxidation number. Okay. So, just till now what an basic concept must have been developed till now is that if you need any element to be electropositive, you need a more electronegative element. For halides, we normally have an assumption that they are the more electronegative element. Yes, they are more electronegative elements. Fluorine is the most electronegative element known in the periodic table. That is why it is always an oxidation number of -1, because it needs 1 electron to complete an octet and it can always accept electron. Fluorine will never give electron, because there is no element known that is more electronegative than fluorine. So, fluorine will always accept electron. If fluorine is accepting 1 electron and only accepting 1 electron just to complete its octet, that means fluorine will always have an oxidation number of -1. Now, the other halides, chlorine, bromine, iodine, generally they will also have an oxidation number of -1 also. If the oxidation number of fluorine, bromine and iodine is minus, that means if they are accepting electrons, they will only accept 1 electron, because they only need 1 electron to complete the octet, right. So, it will be a -1. But there is possibility to have the oxidation number of chlorine, bromine and iodine to be positive also. And how it is? Because there exists an element that is more electronegative than chlorine, bromine and iodine. And what that element is? That element is oxygen. Okay. So, the element is oxygen. This oxygen has more electronegativity than the chlorine, bromine and iodine, right. So, the oxidation states can be +1, can be +3, can be +5, can be +7, depending on what? Depending on how many oxygens and in what form the oxygen has been attached. That means, whether it is attached in case of oxide, peroxide or superoxide. Okay. That I will discuss in the few upcoming slides, that how we will calculate the oxidation number for any element in any compound, right. So, this is the thing. So, generally the oxidation number states of fluorine is -1, always -1. Oxygen is -1 only. It is possible in positive oxygen is possible in positive oxygen state only when it is attached with fluorine, because the only element that has more electronegativity than oxygen is fluorine. In case of chlorine, bromine, iodine, oxygen has more electronegativity. So, it is possible when chlorine, bromine and iodine are attached with oxygen, it can have positive oxidation states. It can go to +1, +3, +5, +7, depending on the number of oxygen attached, depending on number of oxygens. Okay. Now, this 6th one is not a rule, but just one thing to keep in mind, that always the atoms, the sum of oxidation number of atoms in a compound is 0. Okay. For example, I am saying CH4. So, if hydrogen is -1, okay, thus 4 hydrogen carrying a 4 minus. So, it will be 4 plus. So, that means total will be +4 -4, that means 0, because it is a neutral molecule, it is a neutral compound. Okay. But if it is an ionic compound, or let us say ionic molecule, so the sum of oxidation number of all atoms will be equal to what? The charge on the ion, same what I have discussed about the ions. Okay. For example, carbonate. In carbonate, the total oxidation number, that means oxidation number of carbon plus oxidation number of oxygen should be equal to -2, because the charge is -2. Okay. Whereas CH4 has 0 charge. Okay. Let us say H2O 0 charge, MgO 0 charge, Na2O 0 charge. So, the oxidation, the sum of oxidation number of all the elements in any compound should be equal to the charge on that molecule. For neutral molecules, we have 0 charge. If the ion is present, for example, carbonate, for example, sulfonate, the sum of oxidation number of all the elements in the ion should be equal to the charge on the ion. Okay. Just to revise all the things, first I have discussed that any element present in free or uncombined state, the oxidation number is 0. I have discussed the case of hydrogen, H2, Cl2, Br2, Na, Mg, it is not combined with anything, the oxidation number is 0. The second rule I have discussed is for the ions, the oxidation number of the ion is same as the charge on the ion. Na plus oxidation number is +1, Mg2 plus oxidation number is +2, Cl minus oxidation number is -1, O2 minus oxidation number is -2. Okay. Then the third thing I have discussed about the hydrogen and oxygen, because these are the two elements you mainly encounter in calculating the oxidation number. So, I have dealt this with these things separately. Oxygen, generally the oxidation number is -2. Okay. -2 it is present when it is called O, one oxygen having a -2 charge, that means it is called oxide. Okay. If it is present, if two oxygen atoms, let us I have briefly discussed now. If one oxygen carrying a -2, this is oxide, two oxygen carrying -2, that is peroxide, that means one oxygen has a -1 oxidation state, or superoxide means two oxygen carrying a -1 oxidation state, that means the possible oxidation states for oxygen are 0. If it is negative, it can be -2, it can be -1, it can be -1/2. -2 is oxide, -1 is peroxide, -1/2 is superoxide. Now, we thought that whether the oxidation state of oxygen is positive, can it be possible कि we have a positive oxidation state of oxygen? Yes, it is possible. How? To combine it with a more electronegative element, that is fluorine. For example, OF2, O2F2, these are two known molecules of oxygen and fluorine, one having oxidation state of oxygen to be +2, another +1. Then we start with the hydrogen. Hydrogen, we say it can be either 0, +1 or -1. +1 generally with more electronegative elements, that is non-metals, example H2O. It can be -1 with electropositive elements, for example metals, it will be, for example NaOH, it will be -1. Then I have discussed this thing ki there are certain groups that generally carry same oxidation number. Alkali metals, that is group 1, always have an oxidation number of +1. Alkaline earth metals always have an oxidation number of +2. For halides, fluorine always have an oxidation number of -1. Chlorine, bromine, iodine, mainly they have oxidation number of -1. Okay. or 0 in case of Cl2, Br2 or I2, but it can be positive. It can be positive when it is combined with oxygen only. That means, chlorine, bromine and iodine will only have an oxidation number of plus in a positive oxidation number only when it is combined with oxygen element. Rest all case it will have oxidation number of -1, or if uncombined state it is 0. Okay. This is one of the rules, okay, one of the basic rule you have to keep in mind, that always the sum of oxidation number all the atoms in a compound will always be equal to 0. CH4, the charge on hydrogen is -1, the charge on carbon is +4. It is not 0 because there are 4 hydrogen, it means 4 minus plus 4, this total charge is 0. But if the ionic molecule is given, let us say carbonate CO3 2 minus, sulphate SO4 2 minus, then the algebraic sum of all the oxidation number of all the elements will be equal to the charge on the ion. That means, the oxidation number of carbon plus oxidation number of oxygen will be -2. What is the oxidation number of oxygen? Oxidation number is -2 here. What will be the carbon oxidation number? It is, okay, this I will tell how we will calculate. Okay. Now, this we need to discuss now. If any unknown compound or an unknown molecule is given to us, so how we calculate the oxidation number of any element in that? We have certain rules in our mind. Just memorize those rules, just go through those rules, that what are those rules, oxygen, hydrogen, alkali metals, alkaline earth metals, halides, and then we will see how we can calculate the oxidation number of any element in any compound. Okay. One thing you can you will see that the maximum oxidation number of any element is equal to its group number if less than 10, or group number -10 if more than 10. Okay. For example, let us say, because I am saying remember I have cased the chlorine, bromine and iodine, I have said the positive oxidation state can be +1, +3, +5, +7, okay, but it can't go higher than +7, that can be maximum possible. Why is it so? Because it only has 7 electrons in its outermost shell, it cannot give more than that. Okay. So, that is why the maximum oxidation number for any element is its group number if it is less than 10, or group number -10 if more than 10, or let us say group valency, but we say it as. Okay. So, this is the maximum oxidation state possible for any element, it will be equal to its according to its group. So, you see I have discussed mainly about the main groups. We do not you will discuss or you will learn about the D block or F block, let us say transition metals, which we call. Transition metals have various oxidation states. It has various oxidation states, and this you will deal in higher classes. So, we do not have to deal with the transition metals right now to calculate the oxidation number, we just have to deal with the main group, group 1, group 2, and then group 13, 14, 15, 16, 17 and 18. Okay. Group 18, if you say group 18 normally does not combine. So, okay. So, this is till now. Now, in the next classes we will see how to calculate the oxidation number of the element. Thank you so much.